Okay, let's solve problem 339. Determine the magnitude of the resultant force and its direction measured counterclockwise from the positive x-axis. Now we are given the x-axis and y-axis. There exists three forces. F1 is equal to 60 newtons. Its slope is given and direction is given. F2 is equal to 70 newtons as a magnitude, and it makes 60 degrees with respect to the y-axis. And then there is F3, 50 newtons, which acts in the direction of the y. And there exists a bracket. This bracket makes an angle of 45 degrees with the x-axis. So we are asked for the resultant force and direction of the resultant force. Okay, now first thing is to write the right forces in Cartesian form. So let's begin by writing F1. F1 is equal to 60 is its magnitude. Sixty multiplied by its projection on x-axis. So this is, by the way, minus, because it's in negative direction. Cosine 45 I vector plus 60 sine 45 j vector. So the value that we have is minus 42.42 I plus 42.42 J. Okay, now let's write the F2. Now in case of an F2, it is negative both negative in both x and y directions. Its magnitude is 70 newtons, and it makes an angle of 60 degrees with respect to y-axis. So it is x component is 70 multiplied by sine 60 degrees I vector minus 70 cosine 60 degrees j vector. From here, we can calculate the x and y components. Minus sorry for the moment. Minus 60.62 62 2 I vector minus 35 j vector. Now let's calculate the F3. F3 is equal to minus 50 j vector because it doesn't have any x component. Okay, now we can write the resultant force. So the resultant force is equal to F1 plus F2 plus F3, and that's equal to minus 42.42 as you see from here, minus 60.622, and we don't have any x component from F3, so this is I vector plus, now the j component or the components in the y direction, it is 42.42 from F1 and minus 35 from F2 and minus 50 from F3 j vector. So these are the components. So the x component is minus 103.042 I vector, and j component or y component of the resultant force is minus 42.58 k. So this is the resultant force. We are asked for the magnitude of the resultant force and its direction from the positive x-axis. Now we can calculate the magnitude of the resultant force, of course. I will hold you for a second. Now magnitude of the resultant force is 111.493 newtons. Now the angle is certainly tangent theta, that is FRY divided by FRX. Okay, so this is by the way, yeah, the both are negative. Yes, both x and y, so it makes 45 degrees, so this is nothing more than from here you can calculate the theta. Theta is equal to 315.0.96 in counterclockwise direction. Okay,